In this section, we will be using our special triangles again, so make sure that you have those memorized. And here in this section, we will be talking about trigonometric functions of non-acute angles. So we want to look at angles that are larger than 90 degrees, and we want to be able to tell their trig function values. In order to do that, we have to first talk about what we call reference angles. A reference angle is the positive acute angle that is formed by the terminal side of our angle and the x-axis. It has to be the x-axis, so be careful that you're using the x-axis and not the y-axis. Here, let's look at this one first. Here our angle lives in quadrant 1, and we see that it is already acute. So the positive acute angle formed between the x-axis and the terminal side of the angle is itself 60 degrees. So the reference angle for 60 degrees is 60 degrees. So acute angles are technically their own reference angle. But if I get something that's non-acute, let's say 120 degrees, here we live in quadrant 2, we want to look at the angle that is formed, basically the distance between the terminal side and the nearest x-axis. So we actually want to know what this angle is. Well, if I was to go from here all the way to here, of course that would be 180 degrees. Well, I don't want all the way from here to here. I actually only want this red portion. So we actually want to get rid of everything from here to here. Well, if I get rid of that, that's actually 120 degrees. So if I subtract off the part that I don't want, we end up with 60 degrees. That is what we call our reference angle, the distance between the nearest x-axis and the terminal side of the angle. So that distance would turn out to be 60 degrees. So 60 degrees would be our reference angle. Okay. Now let's look at this one here. In this one, 210 degrees, we live in quadrant 3. And what we're looking for here is the positive distance between, once again, the x-axis, the nearest x-axis, and the terminal side of that angle. So I would like to know, what is this distance right here in red? Well, I want my distance to be positive. I want that angle, that reference angle, to be positive. So we always do larger minus smaller. Now, if we think about it, if I go all the way from here to here, once again, that's 180 degrees. If I keep going, of course, that would be 210. But what I would like to do is subtract off this portion that I don't want from the angle. So that would be 210 degrees. Take off that portion from 210 that I don't want, that 180 degrees, and we get 30 degrees. And 30 degrees would be my reference angle. And that is the distance from the x-axis to the terminal side. Let's say that my angle is in quadrant 4. Our terminal side lays in quadrant 4. Okay, once again, I would like to find the angle that is formed between the x-axis and the terminal side. So the nearest x-axis and the terminal side. What would that angle be? Well, when we look at our angle, we see that we are just shy of a complete rotation. If I go all the way around, a complete rotation, of course, will be 360 degrees. Well, I don't want a complete rotation. I actually want to get rid of all of this, because this is not part of my reference angle. Well, if I take off everything except for my reference angle here in red, that's actually subtracting off 315 degrees. So we get 45 degrees left over. So right here, this leftover portion in red is 45 degrees. And this would be called our reference angle. We always want to graph our reference angle first. On the next page, we see that we have sort of a formula for finding the reference angle if our angle is between 0 and 360 degrees. So this only works here if our angle is already between 0 and 360 degrees. We want to graph our angle first, and once we graph our angle, then we're going to look for the distance between the x-axis and the terminal side. If our terminal side lays in quadrant 1, then if our angle is acute, remember we're talking about angles between 0 and 360, if we have an acute angle that lays already in quadrant 1, then the angle itself would be the reference angle. If we have an angle that lays in quadrant 2, then we want to find the distance here. So we want to take 180 degrees, which would be a half rotation, and subtract off the portion that we don't want. So we will actually want to do 180 degrees minus the original angle, and that will give us our reference angle. If we are in quadrant 3, then what we actually want to do is take our original angle, which will be larger, and subtract off 180 degrees. So basically we have our original angle, and we want to subtract off everything that made that half rotation, because we only want the portion that's left over after 180 degrees is gone. So we want to subtract off 180 degrees, and that'll leave us the portion that was left over after that half rotation. If we have an angle that lives in quadrant 4, then we will have an angle that lines up or is closest to the x-axis in quadrant 4. So that's 360 degrees. So if I was to have a complete rotation, of course, that would be 360 degrees. So we would say start with the larger value of 360 and subtract off everything you don't want, which turns out to be everything that was part of the original angle. And that'll leave us that little portion left over that was just shy of that complete rotation. So we'll do 360 minus the original angle. Remember that for these, we will always do larger minus smaller, so that our angle turns out to be positive, because our reference angle is always positive. And we are always working with the x-axis. We want to find out the distance between the angle, terminal side of the angle, and the nearest x-axis. So do not try to find the reference angle using the y-axis. Find the reference angle for the following angles. Our first angle is 294 degrees. The first thing we want to do is graph our angle. So 294 degrees, we're going to put that in standard position. Remember that this would be 0 degrees, this would be 90 degrees, this would be 180, 270. So our angle is larger than 270, so we will be over here in quadrant 4. So this is our original angle, 294 degrees. So we are living in quadrant 4, and we want to find the reference angle. I want to find this portion here in green. What is the distance between 294 degrees and the nearest x-axis? And remember that we want to think of it as the larger value, which would be 360 degrees, minus the smaller value, which would be our angle 294. And that will tell us the portion left over here in green. We put that into our calculator, and we get 66 degrees. So 66 degrees will be the reference angle for 294 degrees. Okay, what about 142 degrees? first thing we want to do to find our reference angle is to graph our angle. So this would be 142 would be in quadrant 2. And this time I'm looking for the positive distance between the terminal side and the x-axis, and I'm going to think about the nearest x-axis as being 180 degrees. So you want to do larger minus smaller. Since this was 142 degrees, it's smaller than 180 degrees. So we will do 180 degrees, take away 142, and that gives us 38 degrees. So our reference angle, that positive distance between the nearest x-axis and the terminal side, would be 38 degrees. So that is my reference angle. Okay, what about 207 degrees? We're going to graph this first. And that should put us just a little bit past a half rotation. And remember that we're looking for the distance, the positive distance right here between the terminal side and the nearest x-axis. Well, in this case, the nearest x-axis, we can think about that as being 180 degrees. But 207 is larger, so we want to do larger minus the smaller. And once we do that subtraction, we will find our reference angle to be 27 degrees. So this distance here, 27 degrees, and that would be our reference angle. Just one reference angle. Now, of all of these angles that we were given for A, B, and C, part D, we notice, is actually larger than 360 degrees. Part A, part B, and part C, all of them were in between 0 and 360. So for part D, when we graph this, we want to be careful to make sure that we know what quadrant that we are laying in. So as we go to graph this, we need to know how many complete rotations we have and then what's left over after that. So let's find a coterminal angle to this so that we can actually graph it. So let's take 360 degrees and divide it into our angle. When I do that, I get 3.14 approximately. So that means I have 3 complete rotations. So let's subtract off those 3 complete rotations. That means I'm subtracting 1080, and that gives me a coterminal angle of 50 degrees. So I'm going to go 3 complete rotations, so 1, 2, 3, and then this tells me that I need to go 50 degrees more into quadrant 1. So this one actually, I can just tell that the distance between the x-axis and the terminal side would be 50 degrees. So that means that 1130 has a reference angle of 50 degrees.